In this video, we'll understand every concept on remainder. But first, what is remainder? Remainder is integer amount left over after dividing one integer by another to produce an integer quotient. If you're dividing a by b, then a is equal to b into q plus r, where a is called dividend, b is the divisor, q is quotient, and r is your remainder. For example, remainder when 17 is divided by 5. So 17 can be written as 5 into 3 plus 2. Here 2 is the remainder. What about negative numbers? If minus 17 is divided by 5, minus 17 is 5 into minus 4 plus 3. If you're wondering why we are not writing it as 5 into minus 3 minus 2, because remainder is always greater than equal to 0. That brings us to the important properties of remainder. 1. As I said, remainder is always greater than or equal to 0, but it is always less than divisor. Let's say we are dividing by 7. Then the remainder can be 0, 1, 2, 3, 4, 5, 6. Why is that? Suppose I am dividing 7 by 7, remainder is 0, 8 division 7, remainder 1, 9 division 7, remainder 2, 10 division 7, remainder 3, 11 division 7, remainder 4, 12 division 7, 5, 13 division 7, 6, 14 division 7, 0, 15 division 7, 1. So after every 7 numbers, the cycle will repeat itself. And this is valid for every number. Second property of remainder is the remainder of sum. If there are two numbers a and b, when divided by the same divisor, they leave the remainder r1 and r2, then a plus b will leave the remainder r1 plus r2. If r1 plus r2 becomes greater than equal to divisor, then divide again. These concepts are better understood with a question. You need to find remainder when 17 plus 18 plus 32 is divided by 5. So 17 division 5 gives the remainder 2, 18 division 5, 3, 32 division 5, 2. Add 2 plus 3 plus 2, this is 7. Since 7 is greater than equal to divisor 5, find the remainder again when 7 is divided by 5, that is 2. If you look at 17 plus 18 plus 32, 67, and 67 division 5 is also 2. That verifies the remainder property of sum. Third important property is remainder of product. If two numbers a and b are divided by d and leave the remainder r1 and r2, then a multiplied by b when divided by d leave the remainder r1 into r2. Understand it with a simple question. Remainder of 11 into 12 into 13 when divided by 9. So this multiplication is 1716. When divided by 9, it leaves the remainder 6. But using the product property, 11 division 9 leaves the remainder 2, 12 division 9, 3, 13 division 9, 4. If you multiply this is 24. Since 24 is greater than divisor, divide again and the remainder comes out to be 6. As you can see, both product and sum property make the question much easier and much faster to solve. Next, we'll talk about how to find remainder of negative numbers in a simple way. Let's say you need to find remainder when minus 24 is divided by 5. For a few seconds, forget about the negative symbol. Simply find the remainder when 24 is divided by 5. That is 4. So the remainder when minus 24 is divided by 5 will become 5 minus 4. That means 1. Let's take one more example. Remainder when minus 48 is divided by 7. Forget about negative symbol. 48 when divided by 7 leaves the remainder 6. So minus 48 divided by 7 will leave the remainder 7 minus 6, that is 1. Now we are left with some important theorems on remainder that applies on numbers with large powers. First is Fermat's little theorem. If p is a prime number, then a raised to the power p minus 1 when divided by p leaves the remainder 1, provided a is not a multiple of p, because if a is multiple of p, the remainder will be 0. For example, if you need to find remainder of 8 raised to the power 16 when divided by 17, here 17 is a prime number and 8 raised to the power 16 is in the form of a raised to the power p minus 1. So without any calculation, using this theorem, you can say the remainder is 1. Let's work on a difficult question using this theorem. If you are asked to find 3 raised to the power 100 when divided by 7, you can see 7 is a prime number. But how do we apply Fermat's theorem here? From Fermat's theorem, we know 3 raised to the power 6 when divided by 7 will leave the remainder 1. So write this 3 raised to the power 100 as 3 raised to the power 6 into 3 raised to the power 6. It will go on 16 times into 3 raised to the power 4. All the 3 raised to the power 6 will leave the remainder 1. If you remember, from remainder of product property, you can multiply all the ones. So now you only need to find remainder when 3 raised to the power 4 is divided by 7. This becomes 81 division 7 and the remainder comes out to be 4. And the last property is the cyclicity method. It works even faster than Fermat's theorem. So remainder of a raised to the power n when divided by d are cyclic in nature. For a divisor d, the maximum cycle length is d minus 1. Let's understand what this means. In this method, you need to check for a raised to the power 1 when divided by t. Let's say the remainder is r1. When a square is divided by d, r2, a cube divided by d, r3, and go on till you find the same pattern repeating. Understand it better with one of the examples. 4 raised to the power 100 when divided by 9. Check for 4 raised to the power 1 when divided by 9. Remainder is 4. 4 square 16 divided by 9. Remainder 7. 4 cube 64 divided by 9, remainder 1, 4 raised to the power 4, 256 divided by 9, remainder 4. As you can see, the cycle repeats after every 3 terms. So the cycle length becomes 3. And to find remainder of 4 raised to the power 100, divide the power 100 with the cycle length 3 and note the remainder. Here remainder is 1. 1 means remainder is first in the cycle and the first in the cycle is 4. If the remainder was 2, we look for second term in the cycle. If the remainder is 0, we look for last term in the cycle. Since here remainder is 1, so the final remainder is 4. I know this is too much for a single day, but with little practice you can easily master remainder.